All right, so we will go over that one first. Grab through this. All right. So we'll just start with the first one, which I was hoping when I gave you a hint that you didn't need to show your work on that. That might help you remember that that was one of the ones where we looked at, if we're just looking at how it ionizes. So that would have been my sulfate, and then my sodium, because I had 2 ions, it would have been 2 times 2.104. So what that would have given me 4.208. So that should have been your number there. I'll get my pencil is dead. I feel like sometimes when I get to this class, things have just run out of steam. All right. So on that one, that was just simply you just ionize it. And since it is a strong electrolyte, it's going to ionize completely. So whatever I started with, that's going to be my concentration of these two. And then this one's going to be 2 times my 2.104. So I would have had up here, I would have had 4.208 molar, and then this one would have been still my 2.104. Okay, that kind of thing only works if it's a strong electrolyte or if it's like a strong acid or a strong base. Okay. And then the next one, what do we have here? What is the molarity of a solution prepared by diluting? So that was just simply an M1, V1, M2, V2. I had maybe a couple of people for some reason change the 500 milliliters to liters, but then they left the other one as milliliters. You could have changed them both to liters. You could have left them both as milliliters, but you can't have one and then the other one on that. You got to have matching units. Because even though we don't show all the math there, they end up having to cancel out on that. If y'all have a question, y'all let me know. Yes, sir.
So on the first one, if it was a weak acid or base,
we haven't gotten to that yet, so I wouldn't have done one of those. And that ends up those are a lot more complicated. Yeah, that's why I wouldn't have done one of those. Because really in Chem 1, we did like everything assuming it was strong or it was going to ionize completely. All right. So then you could have, it would have become more of a math, but yeah, still we have to do something called a rice table and we haven't gotten there yet. So, all right. Then the next one was a little tricky because you had some information in there. So you want to calculate the molarity of the solution. So if you think of your molarity, you're going to have moles of your acetic acid per liters of your solution. And I have how many liters of solution, I just have to move my decimal. So the trick here was to figure out how many moles. And if you kind of thought that's what you needed, then you had your information to get that, because you have 15 mils of the acetic acid, and then I gave you the density. So that would have gotten it to grams. And then once you got it to grams, then you use your molar mass to get it to moles. So that's kind of a typical AP chemistry one. That may even fall more under the multiple choice than the other ones where you're having to use a couple of different things. But once again, like the common thing is moles. If you get stuck on a problem, see if that'll help you out, if you can get some way to get to moles. I just was putting acetic, writing AA instead of writing out that formula for there. Anybody else have any questions on that particular one? All right, my next one, this one was just a pretty typical one. I set it up as stoichiometry, but you probably also could have set it up, Like in Chem 1, we did it more like this per liter of solution. So some of y'all like to fill in that, solve for it, because you needed to get your moles. Once again, you had to get your moles of sodium sulfate, and then you could use your molar mass to get it into grams. And the reality on both of those is, you know, we may be interested in the moles, but if somebody's making something, if I'm making something, I can't figure out how many moles. I can't do that. I have to be in grams, so it can be something to work with. All right. Anybody have any question on those? That one? No? Okay. We shall move on then. Let's see what we have. Our next one was just a typical dilution one. I feel like most everybody got that. Maybe I had a few people that didn't do the sig figs right. So on the bonus, if you were a little bit off on the sig figs, I didn't take it from you. On the other part, if you were real off on the sig figs, if it became a big issue, then you got half credit on them. So some of y'all may have seen minus half, and that would have been what that was. Does anybody have a question on this one? We're good. The next one. So this one, you know, like when I spent that time showing y'all the volumetric flask, and I made a big deal about saying V2 is not only how much water you have plus V1. So I had a lot of people that solved it and gave me the 500 mils. But the question was, how much water did you have to add? So 500 mils would be my total in volume, and I needed to subtract out that 25 mils that I started with. And then that's how much water I would actually have added. And I know we had in Chem 1, we had problem like that also. So just a little bit of a trickier one on that one. So anybody have any questions on that? All right, then maybe we got to some of the other ones that were a little bit, maybe a little bit harder. All right, so this one, how many grams of sucrose should be dissolved in 5.5 kilograms of water to make a 0.175 molar solution? So once again, I'm going to have to somehow get to my moles so I can do that. I gave you the density in case you forgot. I don't feel like you would actually be given that on the AP test because it's a pretty typical density that you should know. So I did some work here that you necessarily wouldn't probably have to show on an AP test. So if I have 550 kilograms of water, that means I have 505 grams. And because of the density, that's also going to mean that I have 5.5 liters. So like if this was actually on an AP exam, you may want to do something like 5.50 kilograms is equal to 5.50 liters. And then maybe, you know, something like because of the density is 1 gram per 1 mil. You know, if you have time on the actual AP exam, I'm not looking for that stuff on my exams, but if you have time on the actual AP exam showing them that you have that knowledge, you know, maybe earn you a point here and there, and a point kind of matters on those. All right, so we did this to get my 5.5 liters of water. And then I had my molarity. So when I did that, then I could find out how many grams of my sucrose I had. So this is a molar mass of sucrose right there. I think 342.34, although I can't really read my writing. So once again, it's just we're getting really comfortable moving through units on that. Some of them you kind of can't have a formula for every single one. Anybody have any questions on that one? All right, so those are the 7 that made up the quiz. So like when you see them worked out, do you think, gosh, I wish I would have thought about that. I should have thought about that. Or are they still foreign to you, like when you see them worked out? Or a little bit of both, maybe. Well, I'm going to say 2 things to that, Elliot. Since you opened the door, I'm going to walk right on through it. sometimes you don't even get your notes out to take notes when I'm talking. And if you're not even using your notes in class, I know you're not doing your practice at home. So that could be why you forget how those things are used, because you're not, you're hearing me say it, and then that's not enough to help you retain it, and you're not doing any backup on it. And that's a reality. Because we all may be pretty smart here. We may not have chosen to take AP, but don't know if it works that easily. All right, now let's look at our bonuses. We had some people get some bonuses. So two of them are kind of very similar because you had to have your balanced equation. Because you're going to have to use your mole to mole ratio. So once again, these are typical AP questions. This type of thing you'll see with molarity. You'll also see it with gas laws too. So on this one, what were we given on our first one? So this is where I started. So this one, so I don't know if y'all remember that I sent out the little message on Sports U where it said you won't actually see any reactions like what we had been talking about in class, but having a basic understanding would be helpful. So this is a neutralization reaction. So that's kind of one of the things I was trying to give you a hint about. So we got a strong acid, a strong base, so they're going to come together to form water. And then what's left over is going to be our salt. So this is my answer. That doesn't go there. I just ran out of room. So once again, it gives me how much barium hydroxide I have in barium hydroxide's molarity. So that right there allowed me to get to moles of barium hydroxide. My question was really about hydrochloric acid, but once I had my balance equation and once I have it in moles of barium hydroxide, then I can use that mole to mole ratio to finish it out. So stopping right here gave me moles of hydrochloric acid. And what else did we need out of that? Then we had the molarity, and so then we could finish it out to find out how many milliliters we needed. So that's a good question. It kind of takes into account several things that you have to do. And maybe you would be a little bit more comfortable with that now that we've talked a little bit more about reactions and types of reactions. I think the same thing with the other one. It was just a basic double replacement reaction where the sodium and the silver swap places. And because everything was either +1 or -1, you didn't have any coefficients. So that I was hoping that may help if, cut down on mistakes. But very similar again, I had information about silver nitrate, but I really wanted to find something about the other one. So you're going to have to get to where you can get to that mole to mole ratio. Because remember, that's always going to be how you connect your known to your unknown. So that's kind of a hint on these two. Like if you get one and it talks about a chemical reaction, it gives you information about one, but then it asks you information about usually another reactant or about something else in that reaction, you're probably going to have to use stoichiometry, that mole to mole ratio, to help you get over to switch over to those two. All right. Anybody have any questions on that one? Yes, sir. Where am I at on that?
0.2 liters.
I did my liters here canceled out, right? And then my moles canceled out here. And then my moles canceled out here. So I did, yeah, so I just followed my unit. Is that what you mean? I don't think I'm following your question.
Oh, I'm saying like if you multiply.
Oh, if I just
moles,
oh, that's just going to give you, that's not going to equal anything particular. Yeah, you're thinking, or are you thinking of like if you take the molarity and you multiply it by the moles, and that would give you liters. Maybe you're thinking about that little part in our notes.
I'm just trying to figure out like.
And I know that some of y'all don't do it like this, and I understand that. So you're trying to figure out a way it would work for your process. I got you. And when I showed these, this is not the only way to do that. Okay. You know, I've told y'all that I'm very comfortable with stoichiometry, but I know a lot of y'all, I can see some of y'all like ratios more kind of, I guess is what you're doing. And that works.
Kind of also the formula for
yeah. So this is definitely not the only way. So I don't know, Glenn, how
I see it now.
Okay. So what were you wanting to, like, what were you hoping it gave you, I guess is what I was gonna say.
Well, I'm just trying to figure out
Okay.
like how to do
And I'm gonna tell you
steps.
this, I feel like you and Ryan kind of do things similar, so like maybe y'all two talking about it, that may also be helpful. Since y'all kind of tend to do it a little bit different, y'all's work looks the same, so I don't know if that helps any or not. Yes, sir. That one, that circled answer, 38.1 mLs. And then the last one was a little bit of a difficult one, but I know I had at least one person that got that right, maybe more than one. On the bonus, the last bonus. Are you good with this one, Glenn? Okay. So all the way back in Chem 1, y'all actually knew what this was. But we haven't talked about it again, so that's why I gave you that formula. Because whenever I originally used this question a couple of years ago, we had talked about it in class. I know we had, and then I didn't have it. But giving you that since it's percent mass, it means mass of my solute divided by the mass of my solution. So that's where I get this 50%. I see it as that, because when I see it as that, then I see it as a conversion factor. So this was a little bit more difficult because you didn't have just a single given. You had, like we've done some of them, where you had something on the top and the bottom. And then what did we want to get? We wanted to end up with moles per liter. So like I said, when I do these, I do them something at one time, one thing at a time. So this was my density here, my first step. So that would have gotten me to grams. And this was the density of the whole solution. And then from here, so it's a little harder to see on this. These two canceled out. This and this canceled out. Because this is solution. This is just of that, what was it? Ethylene glycol. So then if I would have stopped right there, so then if I stop right there, I have my units that I need. I have moles of ethylene glycol per liter. Because I'd got my other units to cancel out. So that was a tricky little problem. Anybody have any questions on that one? That's why it was worth plus 10. I'm dirty. I like a good problem. Makes me happy. And it's good when you get older, y'all have a long way to go. It's good to keep your older brain working. It's supposed to postpone things like Alzheimer's and dementia. All right, what do we think about that one? I heard your head hurt after you left, Mike. I heard your head hurt yesterday after you left. I thought this was Miss Baker said it was at another time.
No, she's asking about it.
All right, any other questions on this? And like I said, if you ever had questions, please feel free to come to my tutorials too if you want to ask them to me privately. All right, so y'all want to look over your test. I know it's been a while, but we still want to look over it. Glenn, you good here? All right. You figured out what works for you? Good. That is what matters. Yeah, I feel like you and y'all do y'all's work a little bit kind of similar. That works. Okay, what am I doing? Say these questions all the time. All right, good old stoichiometry. So on somewhere I just scanned in the whole test. All right, so true, false. Like I said, I only teach this every 2 years. So like I forget how much y'all hate true false whenever I give this test until I'm giving it and I see y'all's reaction. But I feel like people hate true false. Is that a good statement? Yes, okay. It's the only one that has true false on it. And they don't do that on AP. So So I just kind of did some little notes here and there about things that mainly about if they were false, what would have made them true. So like I said, on number 2, it was that isomers that made it, and I didn't talk about that. That really has more to do with organic chemistry. So it's compounds that have the same formula, but they have like, I don't want to say a different shape. They have a different rotation and it gives them different properties. So I hadn't gone over any of that. So a couple of these talked about limiting reactants and what that actually meant. So I kind of put what would have made that more true. On number 6, that was a pretty good little problem. So what you would have had to do, since that was your total amount of carbon, 1.2 grams, then you had to work backwards and you had to figure out your percent of carbon in each of those. So that's what I was doing here. I was figuring out my percent mass of carbon in each of those. And then when I did that, I multiplied it by 1.51. And then got the one that matched up to the 1.21. Which had to be copper oxide. And remember, the limiting reactant is not always the one that has the least grams. We found that out, but you know, it's really has more to do with moles, but then it has to do with mole to mole ratio. So it's hard to make that big judgment call unless you see the whole reaction. And then moving on down. Number 10 is a question that always people hate because they put true on it, which I can see for sure, because you have to have your empirical to get your molecular, but the idea behind it is like you don't have to be handed your empirical. You can be given other things like grams or percent, or sometimes not even all of that, and work to get your empirical. I won't give y'all another true false question. And while I'm thinking about it, our little stoichiometry activity with our cookies will be counted as a major test grade. And then also we'll do it like as a daily grade too. So you can see I'm expecting hundreds for those. So it shouldn't be too hard. It should be a little bit of fun. We'll eat some cookies that day. Talk about the mold. That'll be fun one. It is actually mold day, October 23rd. I have a shirt I'll wear for it and everything. So I had an Alabama shirt. You know how A&M says beat the hell out of, you know, so not, but I couldn't bring myself to wear it today because it was gonna, I'm afraid it's gonna be very embarrassing on Saturday. So I didn't want to embarrass myself at the time. So I left that one out. 10 to the 23rd. That's right. That's right. On Saturday. We could join each other up here on Saturday to celebrate Mold Day. I know y'all don't have anything else to do. All right. Couple of other ones here. One just a little balancing one. On number 12, you had to do a little stoichiometry. Those two that, well, yeah, once you got the answer that matched up, probably a good place to stop, because to figure out that excess, we haven't really done it that much here, but remember in Chem 1, it's a lot of work. So if you did your stoichiometry, then you ended up with your B. You got 10.58, so 10.6. I may have lost I don't know where I get the 0.58 from. Y'all stop me if you have any questions, okay? I'm just going to move on. So some of these were not too bad along here, just a little bit of basic stoichiometry. Tell me here, little percent. I think all that work is for 15, if I remember correctly. Now, once again, I'm not saying that my method may not be the shortest way to get there. So what did I do? I can't remember what I did here. Okay, so I figured out, first of all, I started off here. Oops, did it go away on y'all's end or no? Because remember, no matter how you do it, that if you're trying to find the empirical, you need to find out how many moles you have of each element, so then you can compare that. So that's what I was doing here. I was finding out how many moles I had of hydrogen and how many moles I had of carbon, because I knew my total amount of water and my total amount of CO2. And then, because I needed to subtract here, because on this one, you knew your total amount you started with of that compound. So what I was missing was my oxygen. So that's what I did here. So once again, as I look at this, I'm not saying it was the shortest way to get there, for sure. So what I did here is I took my moles and I converted them back to grams so I can subtract them from that total amount. Does that make sense? Because hydrogen was only in one place on the product side and carbon was only on one place on the product side. So the one that causes trouble here is the oxygen. So once I did that and I found out how many grams was left over, that would have been my amount of oxygen, and then I would have got my moles of each. But that didn't finish it, did it? So at this point, you know how many moles you have of each one. But now you need to see the ratio of them. So you're going to divide by your smallest. So that's going to be a little bit farther down. Ryan, how would you have done? How did you do this one? Because as I look at it, it seems like it did not need to be that long.
This one went off.
Oh, okay. Well, that's okay. What did number 15? Elliot, do you have a different way of doing it? Okay. Well, maybe this is the best way to do it. I don't know. All right. So you want me to move it up some? We good? Or you have a question?
So you can,
Well, you could, no, you could have done that. Like I stopped to find the moles, but yes, you're right. You had to go on and find the grams. So that's what I had. Oh, see it. See, I went back. I had that many moles of carbon. There's my grams, and then here's my hydrogen. You're right. You had to have those two amounts because I had to subtract that from that total. Yeah. Yeah. So you're right. You had to do that. So maybe this is the shortest way to do it. And then finally, when you got your moles at this point, then you needed to see the ratio. So I'll go down a little bit more. So that's what I did on that last step. I, divided it, and I think you got something like 1.5 because the smallest was 0.0136. So I got 1.5. So I had to multiply everything by 2. So that's what that's finishing it out right there. So long problem. All right. Anybody have any questions on that one? No. We'll give it to you again tomorrow. You can get it right this time. Well, yes. All right. All right. What number were we on? What'd you say, Elliot? Yeah, don't ever do that. I always feel like usually your first answer is your best answer. Oh, that's frustrating, huh? What made you change it? Oh.
But I moved it 3 times, so I went back and changed it. So I was off by a decimal.
Yeah, the kilo and kilo and milli both mean 1,000, just going in different ways. And those are kind of your big typical, and those usually are kind of the typical ones you see.
15, okay, it's either B or C. Set that thought about it. So 15 minutes, telling myself to C the entire time. I'm like, you know what? I'm an idiot. Let's go B.
Yeah, just by looking at it, I could tell that it was either B or C. But
So tell me what your thought process. I'm just interested in how could you tell it? You said you thought it was also either B or C? Well, I mean, usually a multiple choice, there's supposed to be 2 that are you could throw out easily and 2 that are pretty close. All right, 16 a lot easier because all you had to do was this right here. I think, does that go? So does that go with that one? Yes. You're going to take your molar mass and divide it by your empirical and just get that ratio. And then molar mass of whatever cryolite is. This one down here, this one always is a hard problem. If you notice, I added in the presence of oxygen to try to clarify it a little bit more. I still think it's kind of a hard question. So it says that you had this mixture and you burned it in the presence of oxygen. And at the end, this is how much you ended up with. So since we know the mass can't increase or decrease, if I take the amount of my compound and I put X for my oxygen by itself, because that's what I don't know, then that should equal my total grams. And then you do a little bit of algebra to find out how much oxygen was present. Do we have anybody that got that one right? Did you do it a different way? If you guess, just say, hey, listen, I guess. Because if all else fails, I say yes on a multiple choice. Okay, that's fine. It's been a while. You're Elliot, that shocks me. All right, moving on. All right, so then we got here, what do we do here? Just a little good old little stoichiometry. And then on 20, you just had to do a little easy conversion. That was a little bit of a sig fig situation too. So really none of them came to be 12.8. We had one at 12.9, 12.93. So, all right. Yep. Because this is a mole. So if you use their molar mass, you could get each one the grams and then you can compare it to that amount. Sometimes after you've done several hard ones, then you kind of don't realize it's kind of neat. I think you did show your work on that one, but you convinced yourself that it should have been around 12. What did you chose the, oh, okay. 0.93, right? Or 12.9. Yep. Because I said, show your work. All right, so then this one was, I felt like we had some people get this one right. Just a typical problem. You didn't have to do all that extra stuff. You were given the amount or given the percent. So you had to figure out your empirical first. And then you had to use the molar mass to go to your molecular. Excuse me. So we may not have time to get to the free response. Y'all have the answer sheet. And I can download what I did too with the work if you want me to, just if y'all want to look over it. And I did, like I said, I didn't take points off. That was like a bonus situation. And probably some of those, now that we started talking about molarity, some of those might have been actually a little bit easier. I'm gonna move past this one, let y'all look at these other ones. But once again, a lot of time on the free response, get lost, go to moles. That was why I put that ideal gas law on that particular one, just to remind y'all, because we haven't used it in a while. And that one that had all the different weights on it, that would, if that, they'll put one like that on an AP test, and that's a sig fig problem. That means all they're really trying to look is how you do sig figs on that particular one. They're gonna grade them hard on that one.
Ms. Laura,
Yes, sir.
what is 98% by mass mean
Where do I have it?
on the last question?
That didn't affect anything. Yeah, it didn't change anything on that particular one. You know how sometimes they'll throw in like a little extra information. All right. So is everybody good on that one? So that was just a limiting reactant one. So then all we had left are all these. And like I said, I've worked them all out. So I'll scan in those and put them in Google Classroom. And then if you want to look at them, some of them, if you look at them, I feel like you might say, oh, should have thought about that. Because some of them you are not that bad. And then there's some that are hard. I mean, they're hard questions. But if you look, once again, it's a lot to do with moles. But one interesting one, not everybody did this one, but on that one that you had to circle a picture, I don't think anybody got that picture right on that one.
The answer. Oh, wait, that's reactant.
Yeah, because you had to notice that you needed the solid PBI. So really it should have gotten down between these two. And then you would have had sodium and nitrate because those ionize a group 1. So the trick was that you had to realize that sodium iodide was the excess. So that meant I would also have some iodide ions in there. So that was the trick between these two. I had a couple of people choose this one, but you had to go that one step. And you'll also notice that the fact that those ions are different sizes, that's like a realistic representation. They're not trying to like make you think you have a higher concentration. It's just actually a bigger ion than the other one. All right, tomorrow we will move on with, and when we go over this stuff, I mean, at this point, if you like go, oh man, I wish I would have thought about that, you're in a good place, I think, okay? Because I mean, this stuff is hard. But, you know, if you look at it and you go, oh, what you talking about, then we need to visit, okay? But if you're like, I wish I would have thought about that, that makes sense, then you're in a good place. I put a new video in there if y'all have a chance to watch it under useful videos, writing net ionic equations, because that's what we're going to be moving to. We'll try to get the cookie stuff together. We'll try to have lab next week. And I'm going to go learn how to dissect a flower. With Miss Foreman. Y'all have a good day. Thank you. Bye-bye. You gonna play this weekend? This week? All right. You ready? Are you gonna put more protection on it? There's nothing else you can do? All right.